So today we're going to cover Chapter 5, Section 6. We're going to learn two more shortcuts, and those shortcuts are ASA and AAS, which stands for angle, side angle, and angle, angle, side. Notice in both of the acronyms there are two A's, but the location of that side or that S is what is going to make the difference between the ASA and the AAS. So let's take a look at the first one. This one is called the ASA congruence theorem. And this one states that if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So notice the letter S is in between the two letter A's, indicating that it's the included side. So it has to be the side that's in between the two angles that are marked with the congruency. So for example, if I wanted to write a congruency statement for the picture of these two triangles, I could start with either one. So let me go ahead and start with the ABC. So triangle ABC, and here I have to match. So if I look at the side where I wrote AB, notice it didn't have the marking, but AC does. So that's the first and the last. So I'm going to match it here with the first and the last. So when I go to put it over here, I'm going to list it as DEF, because D and F, that's the first and the last, and so is A and C. And then you could also look at the angles. Notice angle D has the single mark, and it needs to match with A, which is in the first spot. And then C had the double marking here on the congruency, so A and C and F need to be in the same spot. And again, notice the congruency mark on the side length is in between the two angles that are marked with congruency. So this marking is in between, so this is the included side. This would be using the ASA congruency theorem. The angle-angle side congruence theorem states if two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of the second triangle, then the triangles are congruent. So notice here are my two angles that are marked, but the side that has a marking is not in between. So it's not the included side. So here again, if I wanted to come up with a congruency statement, I could start with the GHJ, and then I got to match it. So notice the G has the single mark, so I need to put K as my first letter. So triangle K. And then the H didn't have a marking, so that's going to match with the L. Put L next. And then lastly, the M and the J have the same type of marking, so I'll put those two together. So then J and M. And this would be using the angle-angle side, because the side that's marked is not in between the two congruent angles, it's the non-included side. So this is just a summary of the 5 shortcuts. These are all the ways to prove two triangles are congruent. So the first one we learned was the side angle side, and that was where if two sides and the included angle are congruent, then you could prove that the two triangles are congruent. Then the next two that we learned were side, 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 and hypotenuse leg. Remember, hypotenuse leg only works for right triangles. And then the last two, the angle, side, angle, and the angle, angle, side, were the two that we just learned. Remember, there are no shortcuts for angle, angle, angle. So there are none for angle, 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 or ASS or SSA. These are not shortcuts. So these are not ways to prove two triangles are congruent. And now let's do some proofs. Okay, so this example wants us to prove that triangle XYZ, which is over here, this one, is congruent to VYW, this one. So I'm going to go ahead and add in my given. So I am given that X and V are congruent. I'm also given that YZW, this one, is congruent to YWZ. And I'm also given that segment XY is congruent to VY. And that's it. So now let me go ahead and set up my statements and my reasons. So number one, let's restate all this given. Angle X congruent to angle V. Angle YZW congruent to YWZ. And XY congruent to VY. And this was all given to me. Now remember, what we need to get in here is 3 markings on these triangles. So far, I've got a side that's marked and an angle. So I need to bring in some other piece of information. And a clue here is, in this lesson, we were doing either angle, side, angle, or angle, angle, side. So this should be a clue that I've got to find another angle. So what I can do here is I really want to look for probably this angle to have markings to this one. That's what I'm going to work on getting. So what I'm going to bring in is the fact that I've got a linear pair here and a linear pair here. So what I'm going to state here is that angle, let me do it over here so I got lots of room, angle XZY and angle YZW are a linear pair. And then I'm also going to do the other pair and show that YWV and angle YWZ are also. So both of these are linear pairs. And this reason is definition of a linear pair. Next, I'm going to bring in the fact that these are supplements, and that'll be my linear pair postulate. So now I'm going to state that angle XZY and angle YZW and YWV and YWZ, these are supplements or supplementary. And this is your linear pair postulate. And you could abbreviate that as LPP. Next, what I'm going to do is show what supplementary means. So my next statement is going to be angle XZY plus angle YZW equals 180. And the same thing below, YWV plus YWZ equals 180. And this is definition of supplementary. Next, what I'm going to do is a substitution. Because they're both of these, so because this is equal to 180 and this is equal to 180, what I can do is take the blue and substitute it, or set these two equal to each other. Or think of this as transitive. So my next statement would be to take angle XZY plus angle YZW and set it equal to the blue. YWV plus YWZ. And this could be either transitive because the 180s cancel out, or you could say substitution. Next, what I'm going to do is I'm going to go back up to what I had from the beginning, and I'm going to substitute. So I'm going to go ahead and I'm going to take out this, let me see, this, because I'm going to go back up to the top, and my given here, I'm going to replace this with YWZ. Because what I'm going to establish is that it's on both sides of my equation. So I'm going to substitute just that one angle. And this side I'm just rewriting. And this is a substitution. It can't be transitive. So all I did was take out that one angle and replace it with my given. So this is substitution. The reason why I wanted to substitute that is now I can use my subtraction property of equality, and I'm going to subtract this from both sides. And now I can show that angle XZY is equal to YWV. And this is my subtraction property of equality. And now lastly, which is this angle that I just went ahead and had put in the picture from the beginning. So these two angles here are what I had put here. So now I have enough information to prove the two triangles are congruent. So triangle XYZ is congruent to triangle VYW, and this would be angle, side. Now, you would not be expected to write something this long on your own. This could be potentially something you would fill in. However, the next proof would be something that you might see on the test where you would have to write the whole thing yourself. So let's take a look at the next proof. All right, everybody good here? All right, let's try the next one. So again, it wants us to write a proof. So let's set up your statements and your reasons. State the given. JL bisects angle KLM, and angle K is congruent to angle M. So they've added in the K and the M for us, the congruency marks. What we have to do is know what a bisector does. So the angle that they're telling me has been bisected is this one over here, the KLM. And when you have something that is bisected, it creates two congruent angles. So this angle is going to be congruent to this. Now I can't just say angle L congruent to angle L. I need to name that with 3 letters. So I can state that angle KLJ is congruent to angle MLJ, and this is definition of an angle bisector. Remember, when we're proving triangles congruent, we're looking for 3 pieces. Right now I have 2 angles. Now I can bring in the obvious that this side JL is the same side for both. So I could state that JL is congruent to itself. So JL is congruent to JL. And this is reflexive. Now I have enough markings in my picture, and I can show that this is not the included side, so I could use my angle, angle, side. And then the same thing here, angle, angle, and it's the same side. So I can state that triangle JKL is congruent to triangle JML by using angle, angle, side. Doing the homework for this lesson, you know that you're learning the 2 shortcuts of angle, angle, side, or angle, side, angle. But when it comes time to take the test next week, you've got to use all 5. So that's where it gets more challenging. So let's go ahead and take a look. So it says, identify the postulate or theorem that proves the triangles are congruent. So notice I've got this angle here of 150 is being shown that it's going to be the same measure as that one because they're both 150. Now the 2 triangles I'm trying to show are congruent are this one in the top to this one in the bottom. So I just showed that the 150s are congruent angles. Then I could also show the 15-degree angles are congruent to each other. And then they've got the reflexive side marked. So this would be using angle, side, angle. For the next one, instead of putting a little box there, they showed that this angle here is 90 degrees. So for this one, I can do quite a few on this one. Now, because it's a right triangle, and notice these are both the hypotenuses, because they're opposite the 90 degrees. And again, the 2 triangles I'm trying to show are congruent are this one on the left and this one on the right. So because I have the hypotenuses marked with the congruency mark and the legs, I could use, and it's a right triangle, I could say, yes, these are congruent using hypotenuse leg. However, I could also bring in the reflexive side here. So I could also use side, 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 or because 90-degree angles are congruent, I could also have done side angle side. So this one had a lot. I don't have markings on 2 angles, just one, so I couldn't use angle, angle, side, or angle, side, angle on this one. And then this one, the 2 triangles I'm asking you to show are congruent are this one on the left, this one on the right. And again, I could add in the reflexive, so I could show that this is congruent to itself. So then I could do side, side, side here, once I mark that reflexive side. Now notice I've got some congruent vertical angles here. So if this one is congruent to this one, and then we can also bring in the fact that they're vertical angles, then I have another congruency mark between the pink and the blue. and I could show side angle side here. I can't assume that this is a right angle, so I could not use hypotenuse leg, and then I don't have any other angles marked, so that one would just be side angle side and side side side. So if you did side side side, besides the given, you would have to bring in the reflexive side. If you were doing side angle side, you would have to bring in the fact that you had some vertical angles, and then you would do like a transitive. All right, one last example. It is a proof. All right, so let's set up our columns. So statements and our reasons. State all this given. Angle FAB is congruent to GED. Angle ABC is congruent to angle EDC. And segment AC is congruent to segment EC. So let's add in these congruency marks from the given. So FAB is this angle out here, and then GED is this one. Angle ABC is this guy up here at the top, and then EDC is this guy, and then AC is this little segment here, congruent to CE or EC. So now, the two triangles I'm asking you to show are congruent are going to be ABC, which is this one right here, congruent to the EDC, which is over here. So notice in your picture, again, you only have two things marked as being congruent inside the triangle. So just like before, we're going to bring in our linear pairs. So similar to the other proof, notice I've got a linear pair right here and right here. So that's going to be my next statement here. So this was given. So my next statement is going to be that FAB, that one that they gave me, and CAB are a linear pair. I'm going to show the other linear pair for the blue triangle, and I can show that GED along with CED, this one is also a linear pair. And this is definition of a linear pair. Next, we're going to bring in our linear pair postulate and take the same thing, but just say that they're supplementary. So again, FAB and CAB, and then the GED with the CED, these are supplementary. And this would be the linear pair postulate. And again, you could abbreviate it as LPP. Next, I'm going to show what supplementary means. And now I take those same angles, but now I'm going to add them and set them equal to 180. And then GED plus CED equals 180. And this is definition of supplementary. Just going to abbreviate supplementary. Next, what I'm going to do is a substitution. Since both of these, this and this, both equal 180, I could cross off the 180s and then just set these two equal to each other. just like I did on the other proof. So I can show that angle FAB plus angle CAB equals GED plus CED. And this is going to be substitution or transitive, because the 180s cancel out if you use transitive. Next, what I'm going to do is go back to my given. And since I was told at the beginning that FAB and GED are congruent, I'm going to replace GED with what it equals, which is FAB. So this is my one substitution here. I'm going to rewrite everything else. So FAB plus CAB. And then over here, put down the CED. And this was substitution. It can't be transitive on this one, because all I did was replace GED with what it equaled from the beginning. And the reason why I did that is I want to be able to show that I'm subtracting the FAB from both sides. So this is getting subtracted out. So then my next statement is CAB congruent to CED, and this would be subtraction, property of equality. And then now I can go ahead and show that angle there. So this is the one that's now congruent. And now I can show by angle, side, and same thing here, that the pink and the blue triangles are congruent. So my last statement was what I was trying to prove, that triangle ABC is congruent to triangle EDC, and what I used was angle, side. Again, this could be a fill-in proof if I give you that on the test. Not something you would have to write yourself. Let me go ahead, I'm going to take a look at the homework and tell you which problems you're showing work for.